We start here with T7A, radio, station radios, receivers, transmitters, and transceivers. And again, some of this is stuff you're going to have to learn and remember, and some of it's stuff you're going to be able to puzzle out. But be sure to refer to the printed material that you have, and to find answers like this, and also take whatever notes you'd like to on that printed material. That's why I wanted you to have it printed and in front of you before we went through the slides here. So our first slide this evening is, what is the function of a product detector? A product detector is a device that detects CW, which you'll remember means Morse code, and single sideband signals. And we're going to be talking in much more detail about single sideband in T8 this evening. We have what's called a block diagram down here. This is different than the schematic diagrams we had last week. Instead of showing the separate components, this shows functional pieces. So here I have a mixer, which is made up of a lot of different components performing a particular function, and in the block diagram we depict it as just a single block there with a name in there. And they're asking you here what type of receiver is shown in figure T6. Now, let me say something about block diagrams. In a block diagram, the signal will generally flow from left to right. There are occasional exceptions. I don't think there are any on the test that are an exception, but the signal will generally flow from left to right. So you start here at the antenna, and you go through the mixer. Here in the mixer you have something else feeding into the mixer. What comes out of the mixer goes to the intermediate frequency amplifier, which goes into this thing right here, which we don't know what it is. We have another something feeding into that, and then out of that we go to the audio amplifier and then to the loudspeaker. So the progress of the signal through the diagram is left to right. Okay? And they're asking you what type of receiver is shown here in this figure, and it's a single conversion super heterodyne receiver. Now, Elsie, how's that for some words? I know. Okay, let me explain that just a little bit. There's a type of receiver called a super heterodyne that converts to different frequencies within the receiver. So we have the frequency that we want to hear coming in the antenna here. Okay, it comes to the mixer, and in the mixer we mix another frequency from here in the oscillator into the mixer. This signal goes into the mixer, this signal goes into the mixer. It comes out at a different frequency, which is called the intermediate frequency. Okay, that's the basic characteristic of a super heterodyne receiver. Okay, and then it goes to this block right here, which in this case just happens to be the product detector that we were talking about here. Okay, so we have another oscillator that feeds in there, and then this converts it to an audio signal that you could hear if you hooked up earphones or something right here. Then it goes to an audio amplifier, and then it goes to the speaker here. Okay, the reason it's single conversion is because it only converts to one intermediate frequency. Okay?
Oh, okay.
If it was a dual conversion, then it would have another mixer and another intermediate frequency farther down the line. Okay? So we know it's single conversion because it only converts once, and we know it's a super heterodyne because it has the mixer and oscillator changing this to an intermediate frequency amplifier. Okay, we talked about this next question as we were going through that super heterodyne receiver. What's the function of the mixer? It shifts the incoming frequency to an intermediate frequency. Okay, and here again we have a slightly different super heterodyne receiver, and you can see here we have the mixer, which is shifting the frequency to an intermediate frequency. Okay, function of the mixer in the super heterodyne. What circuit is pictured in figure T7 if block 1 is a frequency discriminator? Okay, here's block 1 right here. This is the one they want to know. This is black box X. Now let me say that here it's doing something that I told you it wouldn't do, but you can see that the signal flow is still from left to right. We have signal coming in the antenna here, going through this chain, and now we've run out of slide over here. So we bring it back and we put it in from left to right again. Okay, so the general rule still holds. We're going from left to right, even though we had to wrap back around and get back on the left over here. Okay, so they're asking you, if this is a frequency discriminator, what is this circuit? And that is an FM receiver, because a discriminator is the kind of detector that's used in an FM receiver. Okay, so I don't know of any way to help you with any memory aids or anything on that other than just knowing that. Well, okay, this could help if you get this question. Frequency discriminator is going to help demodulate frequency modulation. Okay, so there's a possible memory aid to you right there. Frequency discriminator, frequency modulation. And we're going to have some really good pictures here in a little bit of amplitude modulation and frequency modulation. What is the function of block 1 if figure T4 is a simple CW, that's a Morse code transmitter? Here's block 1, quite simple. We have this thing here. We have a driver of some kind. We have a power amplifier, and we have a telegraph key. This, of course, will switch the signal on and off. Okay, and this driver is an amplifier that feeds the power amplifier. We have everything identified here that we need except a source of the signal. Block 1 is the source of a signal, and a thing that creates a signal is an oscillator. Okay, so block 1 is an oscillator. Creating the signal, goes through the driver amplifier, goes to the power amplifier, and is turned on and off by the telegraph key so that we can send Morse code with it. Okay, what device takes the output of a low-powered 28 megahertz single sideband exciter and produces a 220 megahertz output signal? It's called a transverter, and it's a combination of the word transmitter and converter, and it takes a signal on one frequency and uses a mixer, like we've talked about changing frequency. In this case, we're doing it on the transmit side instead of the receive side, and it's changing the signal that we generated at 28 megahertz. It's mixing it with a signal to change to 222 megahertz, so that you can have a transmitter on this band, which starts with a signal, and a transmitter on this band. If figure 5 represents a transceiver in which block 1 is the transmitter and block 3 is the receiver, what's the function of block 2? Okay, here we have an antenna. Here we have this unknown thing in the middle. Here we have a transmitter. Here we have a receiver. Signal is going to go from the transmitter to the antenna. Signal is going to come from the antenna to the receiver. This is a transmit-receive switch that switches the antenna back and forth between the transmitter and receiver. When we're transmitting, it switches the antenna to here. When we're receiving, it switches the transmitter to here. Transmit-receive switch. Okay, which of the following circuits combines a speech signal and an RF carrier? Radio frequency carrier. It's going to take a speech signal and combine it with that. We're putting information on the RF carrier now. And the device that does that is called a modulator. So we're taking the RF carrier, which has no information on it at all, just whether it's there or not, and we're putting information on it by the use of a modulator. In this case, it's speech, but it could be something else. Which of the following devices is most useful for VHF weak signal communications? That's a multi-mode VHF transceiver. Multi-mode is important here because it's going to have single sideband and CW, Morse code, which are useful for weak signal communications on any frequency. But VHF, and the weak signal for the multi-mode. What device increases the low power output from a handheld transceiver? If you have a 5-watt handheld and you want to, if you need more power, you're hooked up to an outside antenna, you're still not getting as much power as you need, to make your communications. You can connect in there between your transceiver and the antenna an RF power amplifier that will boost the low power output from your 5-watt transceiver to 30 or 40 watts to give you a more powerful radio. So it increases low power output. It's an RF power amplifier. Here's something that we saw in the block diagrams back there. Which of the following circuits demodulates FM signals? It's a discriminator. A discriminator demodulates FM signals. They called it a frequency discriminator before, and that was your key to the frequency modulation, you'll remember. Which term describes the ability of a receiver to discriminate between multiple signals? That is the selectivity of the receiver. You can have a bunch of signals on slightly different frequencies. A receiver with good selectivity will be able to select between those multiple signals to separate them by frequency. Selectivity. Any questions on that slide? Where is a radio frequency preamplifier installed? It's installed between the antenna and the receiver. And here is here's a picture that I grabbed of a broadband RF preamplifier. Here's the input, here's the output. I connect my antenna here, and it amplifies the signal, and then I come out here with the signal to go into the receiver. So what I'm doing, I'm processing this before it gets to the receiver with a preamplifier. Okay, you can see this one has a very broad frequency range from 1 megahertz to 1 gigahertz, which is a factor of 1,000. Okay, that it will amplify over. Most RF preamplifiers are very broadband and don't require any tuning at all.